Okay, fantastic. So yeah, welcome everyone to number 20 of our webinars as Quantum London. For those who are here for the first time, just a couple of words about our community. We started about 2.5, almost 3 years ago, as just a bunch of people curious about innovation and technology, and really wanted to unravel, the impacts implication, business implication of quantum computing as a technology. So we do this, what was just a bunch of people in a pub slowly grow into a community of now we're counting, I think, 3,000 members on LinkedIn. And what we do is we just bring in speakers and experts which can help us understand a bit more about, the technology, what will mean for our businesses, when is this going to happen, how fast it's growing. Super exciting space. If you're here, I'm sure you're as passionate as us about this topic. As you will know, the pace is accelerating, is incredible. We see more and more developments every day. This is coming closer and closer. So, certainly something, we are all passionate about and something to keep an eye on. And so as mentioned, so we have here Paolo with me. He's the co-founder of Quantum London. You might also see Anahita at some point is also helping us to run the events and the group. But tonight we also have Esperanza Cuenca-Gomez. She's a friend of Quantum London, and she's been helping us run some of these events, and most importantly, connecting us with some very valuable speakers from the quantum space. So Esperanza, she's a senior leader in the financial services sector, but also she's head of change management at the Quantum Strategy Institute. It's a newly formed body which is really looking at doing research and spreading the word about quantum. So as mentioned, she's helping us to get in touch with a lot of super interesting people, including tonight we have Robert Loredo. So he's a IBM quantum ambassador and a worldwide lead. He's also a Qiskit advocate. As you will know, Qiskit is the technology and tool that IBM is making available to everyone to develop some quantum computing algorithms, and he also is an IBM master inventor. So we'll be hearing from them. And the topic for tonight is about the readiness of quantum organizations. So how close are we into getting ready for the quantum future? So without any further of me talking, I will just hand over to Esperanza and Robert. Over to you.
Thank you so much, thank you so much, Paolo, and everyone at Quantum London for having us tonight. And I'm thrilled to have Robert today here because apart from being a very accomplished individual, a referent in the quantum industry, he's also a friend and a good person. And that says it all about somebody, I would say. And starting with the topic today, before we get to how can businesses and organizations get ready to quantum, the fundamental question sometimes is, why is quantum important for businesses, for organizations across all sectors? Yeah, it could be finance, but it could be many others, for example, the scientific community as well, or other sectors. So Robert, what are your views on this?
Yeah, so first, of course, thank you very much for hosting me. I'm really honored and privileged to be here speaking with you. And I'm looking through the list. I'm happy to also see some familiar faces, which is one of the things I love about this quantum community is that you meet people from all over the world and they're just as interested and excited about the technology. There's a lot to understand and learn, obviously, right? Because if you're coming into a quantum, whether you're just someone who's interested in it, or you're a developer, or maybe someone who studied it in the past, and now you actually have access to a quantum computer, there's a lot of different activities going on. And of course, now there's access to these devices, as opposed to back in the classical days when you had to have reserved time in a room in a lab and use systems. Here everything is on the cloud and easily accessible. So one of the things I really enjoyed about the way some of these systems are is just that it's available for everyone in the world. Hence why we have this big group that's pretty knowledgeable, I'm sure, on a lot of the basics, at least in quantum. With regard to your question around, what is it that, emphasizes for industry, I think that's usually the the first step in a sense, I would say, right? You always have the research coming up with, pushing science, looking at new ways of innovative ways of doing different things. And of course, with that, you always find some ways of, from the deep science, and you come the applications and engineering. All right, how can we build something to use this to better ourselves, to better some industries, some processes, whether that's in finance or whether that's in life sciences or chemistry or anywhere, even supply chain. I mean, a lot of stuff we depend on is on supply chain. If our supply chain goes down, we have a very big problem. Right. So
Yeah.
we're very connected now, right? And not just
Yeah, absolutely.
so those are things. So of course, with any technology, you go through that, it goes through the pretty much those same paces. With quantum, of course, now we do have the ability to be able to understand, this era that we're in now is quantum ready. So which is just that, right? That's why we with IBM, we work with a lot of partners. We have now over 170 worldwide, all different industries, finance, of course, but as well as chemistry and even academia and everywhere else, right? And it's really just now just that, how do we get ready? The technology is evolving, and every technology evolves, right? We wouldn't have Moore's law this far if we didn't. And if we were happy with 500 gigabytes, which I remember at that time was like, wow, who's ever going to use 500 gigabytes? We're way beyond that. And to go back even further with 500 megabytes, right? So he has used floppy drives, So, we're always evolving, always looking to better. And this is just really no different. It's technology. It's just a difference, of course. Here it's a different technology, right? Think about the days of IoT. Those are interesting devices. They usually started off with smart homes and these interesting gadgets. You can connect to it. It was fun, but now, it's everywhere, right? It's in all our appliances. When we go out and it's in your cars, we wear them now. This one keeps telling me I'm being lazy. Get up and walk around. It's quite bossy, this one, right? So,
Yeah.
So we have a lot of different, devices, how we use it, and it betters ourselves, right? It's just telling me to move because I've been sitting around too long. I got to work out, right? So it's a lot of stuff. There's a lot. We always try to look for better ways of doing this. Quantum is no different, right? There's a lot of new technology that come with it, and of course, the ready phase that we're in now is just that, right? It's not a simple lift and shift. You've heard it many times, I'm sure, right? It's not classic. It's something completely different. So it's not just having to understand it, but having this understanding of, what are its applications, what are its usages, right? Where can it advance? I mean, we're learning things now on how can we kind of better the application we have now. Eventually, just like any other technology, it'll bring up some new technologies that we're thinking about we probably never thought about, right? And it will just expand from that point on, which is great. I mean, this is, obviously right in the very beginning, but I love the fact that it's very accelerated as well, in the sense that everybody is pretty much part of this community, right? I mean, this gathering you have near, I mentioned earlier, this started off as in a pub, a discussion, and now you have thousands of people around the world that are attending this. So I mean, it's just that, it's just because it's availability, you can have access to it, you can learn from it, and people from all different industries are doing it. So I think from an industry perspective, just like anything else, it's having to get that base understanding. How can it apply? How can we apply it? How can we learn? And what can we learn further on? If you want to be that market leader, you got to be a leader, and that lead means you got to get right up front. If you want to just say, well, I'll wait till it's done and I'll be fine. Sure, if that's where you are, right? But in either sense, you got to kind of think eventually, just like anything else, you're going to need to understand it, right?
Yeah, and you highlighted a crucial point there, which is, you can choose to wait and see, or even not doing anything. And this poses also the question of, well, which situations those who, for whatever reason, choose that, which situations are they going to face? Because my personal opinion is that they might risk to be left behind.
Yeah, and with anything, risk is just that. It's an assessment. You show where are you? Where do you want to be? A lot of companies, particularly when it's a new technology, there's always some, right, where is it, and do we need it, and this sort of thing. With quantum, initially, it was just something new. Maybe some folks knew about it, they understood it, and they said, yeah, okay, and then of course there's the well-known Shor's algorithm. You bring that up, every time quantum comes up, Shor's surely the next syllable right after that, right? And that's been around since the 90s, at least as far as the formulas and its theories. But everybody's kind of thinking of it, and of course it varies, right? As so you wanted one of the core things, of course, which is kind of discussion here is no matter what you decide, whether it's going to be, you want to be the leader in it, you want to do it sometime, do you want to be left behind, or do you want to be in ahead, or do you want to just kind of wait and see? The amount of time you put in there is going to be used. A week will pass no matter what, right? So do you want to spend that week maybe just at least looking at some videos, getting up to speed, trying some tutorials, taking some of those lots of free courses online, and there's stuff that we have in our Qiskit community, which is available for free as well. So there's lots of opportunity to really not have to just sit and twiddle your thumbs and wait till somebody tells you to move, right? But the ability to be able to access and be able to start is really just that first step. I think that's something that just with anything, you want to take that first step, because one, you need to understand, because if you're going to be dependent on somebody else to tell you whether it's time to start now, you're really depending everything on that one person.
Yeah,
right? And you want to make
right.
sure that you have this trusted source. So this is why you want to have at least some, if anything, your team at that ready phase, so that they can at least understand the technology. And as a pros, you have somebody there within your team or within your organization to say, you know what, we really need to take a serious look at this, because I see stuff that's moving right now pretty fast. And then it's going to be where you might be too far behind, and it's going to cost more to catch up, right?
Yeah. I couldn't agree more. And the emphasis on the resources, and for example, IBM is a great example of an open source community and accessing quantum computers for free, which I think is something really cool, to be able to design your algorithms, your gates, your circuits, and then running them. Running them on an actual quantum computer. That is amazing. And in this discussion, we are getting to a central aspect, so to speak, which is how can industries get ready for quantum? And in your previous answer, you stressed, or at least I saw it that way, the importance of education. So how can industries and also people get ready for quantum, and what role does education play into all of this?
Yeah, and that's actually a good point to start, in a sense, right? Because when you want to get into it, you obviously have to understand what it is you want to learn, right? Because quantum computing is not just a way to compute certain things, but there's certain things you can compute on quantum computer, certain things you compute on a classic computer. So just understanding how the differences of the two are, what are the advantages and disadvantages of each? An example I always choose is if I'm going to multiply two large, 22,000 bit numbers, I can do that really quick on a classic computer. I can get a product. I have a product. I'm done. It's fast. No need to put it on a classic quantum computer. Now I'll take that same problem and reverse it. I'm going to give you a product, and I want you to give me a factor out the two numbers. Now the classic computer has got to take a little bit more time to understand that, and then where on a quantum computer, there's theories and formulas to be able to do that quicker, right? So there's, it's another so much an understanding of how to use quantum computers, what are they used for, but it's understanding where can we best use it? Where's the feasibility, right? Particularly in industry, you can kind of come up with multiple different, you read some papers now, there's papers regarding quantum machine learning, there's risk analysis and finance and all these things, options pricing, great papers with great theories and great formulations. But now when you look at your applications, you're thinking, all right, now where can we apply this? Where can we start looking? And that aspect is where you really want to kind of focus on, all right, I have to understand where this would be, where's ideal, how my application is running, how to identify, what these particular ways of using them are, and then kind of come up with either a proof of concept or some kind of ideal way to say, okay, what is a feasibility? If I have all this stack, which one place I can put it now? Which one can I do it now? Sure, let's think about shores, but that's probably a little further down the line than trying to solve something that you can kind of just get started and scale, right? So an example with us, we have you mentioned we have the open source stuff, which lots of tutorials, you can actually run a lot of these algorithms on there. But then there's lots of applications and programs that are out, right? We just started one called the Quantum Accelerator, which is purely that. It is education. We meet with, we have clients, we come in, we give them from the very fundamental business and technical foundations, build them up, and then they get the education, the enablement. They then get some discussions on potential use cases, some brainstorming for them to help out, and then proof of concept work, right? So basically develop these proof of concepts. And then at the same time, premium access, right? So as you start off, you're learning, you don't necessarily need to use our 127 qubit processor we just announced this week, but you can start off with 5 qubits just to understand. One, it's easier to see and move things around. It's, you know, it's easy to absorb and get a very intuitive understanding. But from that point, obviously, then you want, once you get that very preliminary understanding, the foundational understanding, then you want to start expanding, understanding how the algorithms work, maybe understanding algorithms within your industry. How do they work? And then from those, you start expanding and you start defining your problem and your solutions. And then when you realize, okay, I think I have what I have and I'm running it on a 5 qubit device. Now, if I want to use some of my actual data, use some feature sets or something, I'm going to need a bigger device that's got a little bit more performance. And this is where the accelerator, for example, gives you premium access device. So you actually get the premium systems that have more qubits and more quantum volume and higher clock. So you can do a lot of this work. But those kind of programs are there because of just that, you know, it's, you have everything from all different levels, from free open source, I just want to try it out and maybe get my team started, to I really want to put some financial backing this. I want to start working on this right now. I have a team, they're ready to go. I'll train them. Let's talk about some proof of concepts and let's start hitting the ground running.
Yeah, that is, I guess, brilliant approach, because it's very much customizable, and it also follows a very logical path to grow in quantum as to quantum in the organization or in the business grows. So it's very organic. I have here a question from the audience about something that you know that I'm very passionate about, which is natural language processing. And Thomas Prosart is asking a really interesting question. He says, in other words, couldn't we say that a classical computer can process NLP of Esperanza, but that it will require a quantum one to process the language of Robert? So I guess, Thomas, your question is about quantum natural language processing, and maybe if quantum can provide some enhancement or advantage in this field. And I think this is a really good question, really exciting.
Yeah, no, it's a really good question. So I did read some papers early on quantum natural language processing. There's actually some really good papers and experiments that have been done so far. I haven't been following it recently because right now I'm kind of looking into medical life science industry area now. But with I guess with respect to that question, where if you train it to understand Esperanza or some kind of, you know, grammatic component, and you want it to understand a different one, there you're still going to have a little bit of that hybrid, right? Because some of the components, some of the activity or some of the work that's going to be done there, right? Part of it we know through, you know, knowledge transfer, right? How do I understand one particular domain or concept, transfer it to a different one, if that's the case here? So not so much as do I know the difference between Robert and Esperanza, but do I know the context of the two, right? So there's going to be some components within it that you can address with quantum, and those can be addressed, you know, some of those papers talked about how do you basically determine the grammar and be able to understand some of the diatonics around that particular language. But now on the other aspect though, you know, what part of that particular component can you, again, just depending on the problem, can you optimize using a quantum computer, or maybe just use a classical computer to do your pre or post processing on it, right? Because with everything, you're going to have some. Your data is coming in classically from either a repository or some sensors. So you're always going to have some kind of classical data. So that you're going to have to some kind of prep. But before that, you need to kind of figure out, all right, what part of my, as you mentioned earlier, what part of my application do I want to do this? And then what part would I want to do on the quantum system? Then you have to do this prep, this pre-processing of prepping the state or preparing your problem and your solution. So for example, in Qiskit, you know, with the Aqua, you have ways of being able to define the two. You define your problem, you define the solver, and then you go. So very similar here. You have a problem, you have a particular language or some new domain you want to put in, you do some knowledge transfer on it, you apply a particular algorithm, quantum natural language processing for some particular work. That gets processed, you get your results back, then you have the post-processing to do. How do you analyze the results? How does that apply to your application, right? And then you do those back. So with respect to that, there are ways to do it. It's just like anything else, you have to kind of know pretty much where do you want to make that connection out to a quantum system and then bring it back. And of course, the preparing and post-processing of it.
Yeah, and that is that the way that works, it's a beautiful field. So, and then the team at Cambridge Quantum Computing has also done a very interesting work in this realm with Lambaku. So Thomas, if I may make the suggestion, what I would suggest is that you also take a look to this work, and then why not experiment yourself on the IBM Q experience. So you can run your models and see how the thing goes. I have, in a sense, these questions from the audience were expected because, well, IBM did a pretty impressive announcement earlier this week. And another Thomas Clark, is asking is asking a question about this announcement and about sorry, Thomas, I'm trying to read your question. Thomas Clark, he's asking, he says, out of curiosity, with the new 127 qubit Eagle QPU, what are you looking forward to do with that? And he also adds that it should be about 2 to the 62 power more powerful than Hummingbird. This question was, of course, expected. We were going to have some discussion about this announcement, and I feel very lucky to have somebody from IBM here in the discussion.
Sure, no problem. So yeah, so we made the announcement about the Eagle processor earlier, and one thing that we did obviously is that it has more qubits. Clearly, right? We mentioned 127 qubit processor, but also it's what we've done from that also is like what we've done with all our processors. We've learned from the previous processors, optimizing the circuits or the hardware. How do we actually implement those on a circuit? How do we run it onto the platform and the infrastructure, these sort of things. So the Eagle processor gives us that ability to be able to manage all of those components. So that obviously, besides giving us more power, we're able to, because we crossed that 100 qubit thing for a gate-based processor, quantum processor. We're now at a place where you cannot simulate this with a classical computer. You can do things if you use it to its full capacity, as Thomas mentioned here. You can start doing some calculations that are above and beyond what you can normally simulate on a very powerful system. Example, on our IBM Quantum Experience or IBM Quantum Lab site, we have some simulators there that we can use for COSM simulators. And right now, those are peaking at 32, 33, and it's sitting on a Power 9 server. So, to extend that and use, as much as you can, you're now getting into those areas where you just cannot, simulate a lot of those things, which is an advantage that we want to kind of understand, because now how do we express the power? And of course, we have plans next year for a 433 qubit, and then of course, the year after that, 2023, for the 1121 qubit Condor processor, which is that what we're saying, we calling that inflection point, because now we can actually have multiple and stack these particular processors into one unit. So with Eagle, of course, it's a new device, so people are anxious to get on it. We have it released, so we're going to be making it available for our premium users, et cetera, so they'll have some good access and actually start experimenting into that new realm that we're looking into now. Yeah,
and it's very exciting to see how we are seeing machines with more and more qubits, and see what we could do with them. It's indeed exciting times. More questions popping here from the audience. Oh, and Thomas Clark, he says thank you. Of course.
Anytime, Thomas.
And Christian, I think Christian's question is about understanding bias and data sets. That is of course something to pay attention in machine learning and in quantum machine learning, of course. Mm-hmm. And his question is about the role of the developer. If the developer must actively unbias the algorithm during post-processing.
Well, I think biased data is something that's just that's something we want to fix. We don't want to have biased data. We want it to be as as unbiased as possible, right? And those techniques can be done in either one, classical or quantum. If you can figure out a way to do a quantum, great, right? So I think overall, the developer shouldn't think, well, this is quantum, I'm not going to worry about it. Obviously, it's something you want to look at it completely. So if within your algorithm you find some way of leveraging quantum to help in determining or identifying or maybe even likely preventing it, that of course is excellent, right? It's innovative. It's really a great way to apply it. But as far as the techniques to go about doing it, it's just another technique, right? You just need to go through and figure out, okay, if this data is coming in biased, how do you change it? If it's because of some of the data coming in, is not data, garbage in, garbage out, right? So if data needs to be cleared out, find a way to kind of mask it or obfuscate certain data that's basically doing that, right?
Yeah, I agree. I agree with you. In the end of the day, bias is something that can happen in any technology, and it's always a good thing to try to get rid of that. What I would also say is that maybe it's a good thing to be active, and then this discussion also goes beyond data sets. We could even enter ethical implications that may be out of the scope of this discussion, but it's a fascinating question. Yeah, thank you so much. And another question from the audience, and I love it, this being so interactive. Craig is asking about the balance between processing power and application development. And if you allow me, Craig, I find your question interesting because sometimes it depends a lot with which side of the question you ask. When I talk to people working very actively in developing algorithms, then you talk to the people working in hardware, and they say, no, they are too busy doing algorithms, but they need machines. We need to put more focus into the machines. And then if you talk to the people working in algorithms the other way around, then the guys working in algorithms, they say, well, the guys doing the hardware are too busy chasing processing power, but we need the algorithms. So it's a funny discussion when you talk with both sides, and it's even funnier if they are together in the discussion. Then it's very, very fun.
It always depends on where you're standing, as they say, right? I mean, I remember this brings up memories when I was, early days of computers. I remember when we had the dial-ups, and I remember hearing that awful noise that we do when the modem is connecting, and you're like, come on, hurry up! I want to check my email. I want to go online. I want to, And then on the same side, you have the hardware guys that are sitting with a fiber optic cable, going, come on, who's going to use this stuff? Let's get going, right? So it just depends on where you are, right? But from I guess I think it's not so much there's one side chasing it more than the other. Both sides are equally growing. The hardware, as you can see, our roadmap for me is a perfect timeline to just show. I mean, we went starting from the earlier processors where we had our 27 qubit, 65, 127, 433, 1121, and beyond. This is like 1 year after the other. So it's we're kind of, the hardware seems to be really moving along. The development stack, and some of you that might have seen or not seen the IBM developer roadmap that we have, very much follows that same hardware. I mean, we have, as a processor comes out, we have stuff that's on top. In fact, in this particular case, we announced our Eagle processor 127 just this week. A few months ago, we had our Qiskit runtime, which basically is just a platform for software. So you have the software coming up, and then you have the hardware, and then you have it vice versa. Now you have the hardware. Now we're going to have software updates that are going to be coming in with this stuff. So I think it's not so much it's one waiting for the other. They're both progressing, I think, right now at a very good pace, because it's not too far off in the distance. I remember my chemistry teacher when they were teaching me in college, and I told you the story before, it was talked about quantum computing, and I was like amazed, like, wow, there's systems that do this. Yeah. Well, when do we use it? And I remember him telling me distinctly, you're not going to see it in your lifetime. Maybe your grandkids will see it. And lo and behold, here we are. We have one. So you never know, right? But yeah, I think the push is on both. I mean, if you look at all our research papers, just out of the IBM Quantum Network, we're at over 700 papers in all different industries, all different domains, from finance to machine learning to chemistry, all different areas, aspects, optimization. There's a lot of research going on, and of course, all of these are, even in finance, we're talking about options pricing and risk management and these sort of things. So There's a lot of activity with applications and how usage. How do we use these in these domains, in these industries, as well as the hardware that we're now applying. One thing that's really in the middle that I'm hoping people will do, at least hoping this audience that we have here will do, is, there's advanced on both sides, but you want to be able to have enough understanding on both so that you can not only understand, oh, I see, I have this problem, I'm running it now on the, let's say, the 127 qubit device. Perfect, I got it. It's really nice. I can now. How do you scale that? Now, next year after that, we're going to have 433 qubits, and after that, 1,000. I mean, after that, 1,000,000. Now, you're not just going to copy paste your formula multiple times, right? How do you scale your problem? How do you understand how to expand that solution, right? So there's a lot of things really that goes into having to understand not just the software, your algorithm, but also the hardware. How do we scale these problems? How do we take advantage of these things, right? It's not just I have all these qubits, let me play with it, right? Now we get into the larger numbers, we can actually start talking about logical qubits as opposed to physical qubits, right? Error correcting, that's a big thing, right? All that stuff that's still going to get piled up under there. So there's still a lot of growth, but I wouldn't say one's kind of racing the other or we're waiting for the other. I think they're kind of right now in some good harmony.
I'm getting here a lot of questions, and I'm going to address them. So calm down. But before I get to address those, there is one question that I don't wanna miss, and it's about education. And this is a discussion that I have with different people in all sectors, and it's about the role of education in a quantum journey. Related to this is also education is different for everyone. So, and for some people, the orthodox education doesn't work well. So the question that I want to address now, and guys, I will address yours just after this, is which resources would you recommend to learn quantum? And specifically for those who doesn't feel quite comfortable in the orthodox way of learning?
Yeah, that's a really good question. So, and you're right. There's, when you want to jump into quantum, one, you have not just different levels of people that understand. Some people are brand new, have never heard of quantum. Some people never programmed. Some people never just, they just want to understand it. Some folks are programming and they want to understand it. Some people have some knowledge and they want it. So all different levels. So one of the things that we did early on, particularly in the Qiskit community, was, initially I remember vividly, it was this one very large user guide. It was just a user guide, it just very long, and it was very, it started off fairly simple, then it got really difficult, really hard. So one of the researchers, she actually created a smaller sort of a quick guide to get you started. And that was easier to consume. A lot of people use that. And then they went to the deeper one if they want to get in there. But since then, of course, like everything else, we're evolving, and education was definitely something that we wanted to. There was too much of a learning curve in the initial stuff. You start very easy, all right, superposition, entanglement, some of the formulas, and then all of a sudden you're shooting up the shores and, quantum Fourier transform, and it's this big myriad of formulas and things that people just get lost. You lose a lot of people. So one of the greatest things I think that I still, I'm happy about the stuff they're working, but they have a beta now, is in the Qiskit textbook, that they were able, the Qiskit community in a sense was able to put together not only a textbook like any other textbook, an online thing you read and let me go try it here. It's interactive. It kind of couples all different modalities of how people learn, right? I learn by images. Some people learn by looking at formulas. Some people are just intuitive. They can picture things. So it has a little bit of everything. So it has a description, it has the formulas, it has some code. You can try a little bit at a time. So it literally holds your hand and walks you through this sort of, this learning path that you have. So the Qiskit textbook is definitely an excellent resource, I say, for anyone just to kind of get brushed up on the basics. And if anything, some people just know a lot of formulas, they want to know the programming. Some people are new to Python. So this helps you kind of get those things started. So from that aspect, I say that's easy. Well, obviously, and it's free. So you don't have to invest anything. You can start using it right away and you're good to go. Now, a level from that above is, okay, now you want to get a little bit more deeper involved in these things, right? So we have this Qiskit summer school that they do once a year. This last summer.
Yeah, and it's great. I have attended both, and it's great. I'm already looking forward to the next one.
That's perfect. Great. That's the kind of feedback we like to hear. Yeah, it's fantastic. I mean, it literally takes you from, I say, 0 to hero, right? You're 0, you don't know any knowledge. It gives you the basics. It gives you even background on classical machine learning, and then the quantum applications on there. And you have labs, you have notes, you have everything there, video lectures, all of it. So that is great. It's 2 weeks. It's, you know, you can watch it. Obviously, it's recorded now, so you can watch it at whatever pace you can. So those are really good because that kind of takes you in. This year was quantum machine learning. The year before, which we have up there, was on variational quantum eigensolvers. So it was more chemistry based. So they do those areas. And of course, the Qiskit community has a ton of things. If you haven't already connected Qiskit community, please do. They do hackathons. They do, you know, these challenges, which are great, I think. I mean, if you really want to challenge yourself and you're bored, this will definitely wake you up. It'll keep you up, if anything. I remember the first couple that I tried to do, it was just, you know, poking my forehead so much, just trying to think. But they're great. I mean, you see, you really learn from it. And of course, it starts the same thing. You know, it starts very basic, so everybody can participate, and then it goes a little more terrific. I think it just progresses in difficulty, so you can actually push yourself and challenge, and they give you enough resources to learn, etc. So it really is a good opportunity. And then of course, then there's the commercial engagement type of perspectives. As I mentioned earlier, this quantum accelerator, which is just there, just basically do those 3 things. You know, it's education, enablement, proof of concept, and of course, premium access to these bigger devices. So.
So yeah, that I think it covers all the points in the education side of things. And there is something also embedded in education. And I speak also from my experience, particularly in the quantum summer school, and it's the community. I mean, education is much more than education. It is the people you meet, the discussions you have with them. And yeah, all those things really make a difference. So, and I think it's the core element for any quantum journey. Yeah. All right, now going back to the questions from the audience, and I love that everyone is so active. Here, there is a question about the relationship between quantum machine learning and chaotic systems. And this question is posed by Wasim. I'm not sure I have pronounced right your name. I'm sorry, but it's fascinating in the sense because, and this is something that I actually haven't thought about, the relationship between quantum machine learning and chaotic systems, like for example, the stock market. That is a very, very good example. And also where a fluid is also a very chaotic system, and we struggle about how to modulate the behavior of a fluid. And I'm saying this because I'm passionate about aviation, and Robert is too. So we think a lot about how can we model better the behavior of a fluid so we can fly better, right? And Wasim, I'm sorry about, I think I'm not pronouncing it right, would like to know about thoughts on this, on the relationship between quantum machine learning and chaotic system. And a really interesting question, can quantum really solve the chaos theory problem? Well, that's a very profound question.
Yeah, and forgive me, because I remember reading about it and understanding chaos theory years ago, so I haven't really been up to speed on the latest on there. However, with respect to the question here, you know, on applying quantum to these sort of chaotic systems, or to, I mean, you know, I guess it depends on how you want to tackle the problem, right? I mean, right now, if you look at the stock market, things, most of it are simulations, right? You can do simulations based on events that trigger certain things, right? And there's lots of papers right now that we know of, and things that we've done ourselves in areas of finance with respect to, you know, simulation, Monte Carlo simulations, and these different types of techniques to be able to simulate those things on a quantum system, right? We've shown some quadratic speed up on some of different advantages, and there's also some papers, I think, some of our IBM Quantum partners that have also worked on different areas in finance, JP Morgan Chase as well, and Mizuho. So they all done a little bit of research. Keio University was a university hub. They've done work on these types of finance and ideas. So with respect to this, yes, there are particular ways of looking at in the finance industry, particularly on how to simulate certain things on events. Obviously, they're at a small scale of what we call a toy problem because it's just the size of the devices that we have now. But what that allows us to do is understand pretty much how we can apply these techniques to be able to simulate some of these things. And then as I mentioned earlier, as the devices and machines start to scale, how do we scale this up? And even the applications, how do we optimize this application? Right now, there's a paper recently that was written about using black shoals as a simulation on the quantum system, right, which is much more difficult than the general Monte Carlo simulation. So there's always different research going on different ways of being able to simulate. So from that perspective, I think there's a lot of work, a lot of opportunities in there. Directly to something like chaos theory, I haven't seen anything, but that doesn't mean it's a bad thing. For me, it's try it, give it a shot.
Yeah.
See what there is. It's one of the good things is, you mentioned master inventor. It's one of the things I love is getting into this vast unknown area of something like this, or just thinking outside the box, right? If you think of it, then you can come up with something innovative in that area. So awesome. If you're thinking in chaos theory or solving chaos theory problems, I say go for it. I myself have not. I'm honest. I have not looked into that. For me, it was trying to be funny. It's too chaotic for me to kind of understand. But it's definitely. I think I would say just give it a shot. See what kind of opportunities might come.
Yeah, and I absolutely agree. I would encourage you, Basim, to look into it and research about it and write a paper about it and explore this fascinating intersection of quantum machine learning and chaos theory. And it's a great question. And this brings to my mind a great sentence by physicist Sean Carroll. He said, ask yourself questions and then try to find answers. So yeah. Another question here from Jagan, and it's about CANS simulators. I think I'm not pronouncing this very right. Arctic CANS is CANS simulators on power systems. Any plans to have it on set? Just curious.
Yeah, that's good question. I don't know. I could probably ask the Z team and see, hey, what you thinking? But I have no idea. That's something I'm not really in that platform level discussions, but I can definitely, it wouldn't hurt to ask. Sure. I think right now, when they did it, just had a power system and they said, well, let's use this one. But good question. I can ask.
Great. Thank you so much. There is another question from Craig about risk management and asking about if you can expand on current activities.
On risk management? Well, yeah, I guess. Well, recently there's been some papers that have come out on other areas. I mean, I don't know if anything specific to risk management in that aspect, but there are other industries that are looking at it because obviously risk management is something that's broad. It's not.
Yeah, absolutely. Absolutely.
So a lot of the work, at least a lot of the work I kind of see where people are just, learning a lot of these things is that they, some company in one industry wants to learn what this other industry is doing because it's just, can we find an innovative way of applying these things? One of the things that I'm seeing a lot of folks doing is trying to generalize a solution. So someone solved a problem in this industry, in this domain. That's great. They'll get that and they think, well, how can we generalize it now? How can we make it in other domains or in the same industry in different areas, these sort of things. So I think that's sort of where that's coming into play more now. And of course, the reason for that is that we're talking about this education is because some of them had educated themselves enough to understand, okay, I see how you solve this problem. Very interesting. Now, I think I could probably solve it here. I might have to tweak a few things, or I might have to do some pre-processing or whatever the adjustments need to be made, but you can make that adjustment, or you can find a way to apply it to a different domain, maybe in a whole completely different form, right? So I think under having that level of understanding and being able to analyze a particular solution, not just let me see what the problem is, but what's the solution, how was it solved, what particular principles are they using it in that aspect, and then applying that somewhere else, right? Because I don't think it's going to be a simple just let me just put my data in there, which if it is great, but I think it will require something. So again, this is why we're discussing these steps here, is to be able to, and that's pretty much helps you get to that, again, that lead, right? Because you may be in some industry and you're competing with somebody else in your industry, let's say, but if your team has a way of understanding some other domains or some other industries and being able to apply it, now you're sort of accelerating yourself in there, right?
Yeah, absolutely. And this is why in this talk I wanted to go beyond finance, in a sense, because very often you get inspirations to your problems talking to people in other industries. And for example, regarding risk management, I get a lot of insights from people in the insurance industry, which is pretty close to finance, fair enough. And then curiously, from people in aviation, when I talk to them, sometimes the underlying principles can be applied to a variety of industries. So yeah,
you think about insurance, right? They're I mean, they are in the finance industry, but it's risk analysis, and they have to understand all the other industries. Or some insurance companies are insuring people in finance, but they're insuring people in I don't know, construction and these sort of things, right? So there's risk analysis that needs to be done in all those areas, right? So how do you understand to apply some analysis in different areas within those domains? Yeah,
absolutely. There's here a lot of questions are coming in. I apologize in advance if I'm not able to address all of them. Van Borde is asking a provocative question, and he's saying, do you think we will see a non-trivial quantum advantage in the Qiskit era, in finance particularly? Well, finance is tricky, in my opinion, but yeah, it's a great question. Van Borde, thank you so much.
Yeah, no, I think, well, so it's sort of depends, right? So when some of you have watched the replay or when the YouTube where Jay talks about the announcements and everything they made, when he talked about legal processor, for example, he said, we're just entering this quantum advantage land, right? It's not a point, it's just this broad area. So because quantum advantage, people say, when is it? When is it? Like it's a date or time or something, like one thing happens and then that's the whole thing. It's obviously going to happen in different areas, different parts, right? Some problems might be like as Van Borde is saying here, is it might be something non-trivial. It might be, okay, we're substituting it and we're getting a speed up. Great, it's an advantage, right? It's an app. As long as you're applying a real world application, and there's an advantage. And of course, advantage, we're talking about not I can run this twice as fast on a computer. Quantum advantage in a real world, we're serious about it. It's got to be something where it would be impossible or intractable for a classic computer to do this. So non-trivial, yeah, because I can add two numbers and I'm 0.5 times faster or something. We want to be thousands of times faster or much more accurate with less samples, perhaps, right? So I think that advantage will come in pieces. It'll come, based on, it could be in finance, could be in chemistry, could be machine learning. Nobody really knows. It's just that when it happens, again, it's going to happen. Someone's going to say, here it is. We solved this problem using quantum on a classic computer. It takes this long. Quantum computer takes long, and we're actually solving it in a real world problem. This is not a lab. This is an experiment. This is, here it is. It's being used. You can now get your Starbucks coffee faster. So, I would be happy with that, right? But generally, you want to, we're looking for something of that impact, right? So I think that would that happen? I would be delighted if it does. If I don't really, otherwise, you don't really know. My crystal ball doesn't look in that well.
Yeah. It's difficult to know, but my take on this would be, if it can happen, it will happen, and it looks like more likely day by day. So let's keep a close eye on this. There's a question here from Rishi, and I love this question because it has to do also with ways of learning. And Rishi is hitting absolutely the nail with this. He said, quantum learning has a hard learning curve. That's right. And he asked, how can inculcate I think, in ourselves to unlearn classical thinking and think and process in a quantum mindset. And he adds, definitely, finding the relationship between quantum and real problems is far from trivial. So this is a brilliant question, Rishi. Really, I love it.
Yeah, and just a good point. I mean, I remember when I first started on the first class for the quantum ambassadors, Jay Gambetto, who was our IBM fellow and VP of quantum, he, we were asking him questions, and he just kind of set up, and this is his famous quote back then, was, "You're thinking too classically." Because we were, I've been trained to think a certain way. I learned this, and I'm trying to figure out how do I get an analogy to kind of sit with what I'm looking for. And that's the first hurdle. That's the first challenge everybody gets. It's, it's kind of getting that, disconnecting for a little bit, right? The classical training that you've had, or at least know how to not depend on it to be able to explain what you're learning in quantum. And that is usually the first hurdle. I mean, most people just have, talk about superposition. When they say 0 and 1, they say, well, it's a combination of 0 and 1. It's not 0 and 1, right? When you get your results, it's one or the other. It's just a probability. So I think that goes into the education, and again, you want to be able to kind of understand what all the different quantum principles come in, so it helps you understand. Once you get the fundamentals in, then you can start, moving up. I would say gently move yourself up. Don't try to jump up and say, well, now give me this big thick book and I'm going to read it all about, quantum.
Maybe not a good idea to start straight away with Chuang, with the book of Chuang. Maybe not a good idea.
I mean, yeah. So yeah, you definitely want to make sure you progress yourself. Everybody, we all learn differently. So yes, I do. Yeah. You definitely don't want to jump on something, but you'll know when you hit some spot. The difference, of course, back then and now is when you get stuck somewhere, there's tons of resources everywhere now. You got the Qiskit community. You go to the Qiskit Slack channel, post a question. Yeah. 100 people will respond with an answer or a notebook or some example that they'll point to. So there's plenty of resources. So I think right now that is a hard part. The learning curve, I feel at least that the learning curve has shallowed down a lot comparatively to where it was before. Can it still shallow more? Of course, right? I mean, I'd love it for a quantum course to be a 1 semester long and then you're good, but we're not quite there yet. But eventually, I'm hoping that quantum will, or at least the fundamental components, right? Linear algebras and these sort of things are kind of more required, because as you need that in order to get in and understand a little bit better. So there's a lot of fundamentals to pick up. But I think to the second part of your question or your comment on, how easy is it to kind of move from understanding quantum and now applying it to the real world. That's where you need to do some of the kit, like I mentioned. The Qiskit textbook has a whole section on applications. I co-wrote some sections around quantum image processing, for example. So you can look at how things are applied in certain ways, and that kind of helps you. There's a whole thing on machine learning as well. I think there's a PyTorch integration piece where you can use a quantum neural network, where all the hidden nodes are basically your qubits. So there's different ways. So my thinking always is, don't just look at, okay, I want to look at machine learning, so that's what I'm going to learn. Broaden yourself, learn about the Qiskit runtime, because that's pretty much how do you speed up your processing power, right? Or use your computational power going across from an infrastructure perspective. And then look at the formulas, the algorithms in different varieties, because like I said, you never know where one will lend itself to another, right? And I think it's just slow progressions would usually help.
Yeah, and what I absolutely agree. And what I would add, and you highlighted very well the point, Robert, is join the community, embrace the community, and leverage on the community, because the struggles we all go through, other people is going through that as well. And a beautiful thing about telecommunications is that is this fantastic global community of people willing to help. So, and they will help you and you will be helping others. And that is also incredibly gratifying in the sense, because you feel you belong. So I would encourage the audience. Well, I can speak from experience in the case of IBM, but I'm sure there are others as well. Join a community, join, for example, a meetup like Quantum London, get involved, learn and talk with others. as well as in addition to your own learning, because I feel it's the community what is actually, I don't know if making the curve less steep, but at least you are not climbing the hill alone. You have others to climb that hill. All right, we are reaching the top of the hour. Again, I apologize. I apologize for the questions that I could not address. I'm sorry. I'm also monitoring the chat and I see amazing discussions here. So again, I would encourage everyone to somehow keep in touch and keep on these conversations going. And then Paulo Anne, over to you.
Esperanza, thank you so much, and thank you to both of you. IBM as a company has always had a special place in my heart, as my first ever job offer came from IBM back in the 90s, and sadly I wasn't able to take it up because of the geographic limit. But I've always looked at it as a fascinating organization, and clearly, or one presumes, IBM's aims are very commercial in terms of the scale of investment being made in quantum computing. However, the enthusiasm that we see and the passion with people like you, Robert, and we were so lucky last year we had Andy Stanford Clark talk to us as well.
Yeah.
That transcends sort of any commercial organization, right? And I think Esperanza talked about the community and the importance of community, and that does come from individuals such as her, such as yourself, but also companies who realize that and who therefore support the development of communities. And words like advocate and things, those only come from companies that realize that we will achieve the aspirations that we all have if we work collectively together. So we really appreciate your time. We appreciate once again Esperanza giving us the access to her network of people like you. We appreciate the questions people have. As you said, Esperanza, there's more questions there than we were able to cover. That's reflective, I think, of where the audience is getting to in its sophistication. I remember when we started these online at the beginning of lockdown, there were very, very few questions, and most of them were silly ones like, oh, what does this mean for Bitcoin? And we hit the sophistication and engagement of everyone has increased. So once again, thank you. Really look forward to staying in touch as Quantum London with what you, Robert, and what IBM are doing. Thank you again, Esperanza, for hosting, and we look forward to your next speaker at some point in the near future.
Thank you very much. I appreciate it.
Yeah, thank you. Thank you all for having us today. And thank you everyone at the audience for the amazing participation. And I'm also reading now incredible comments to you, Robert. Everyone is clapping, saying very inspiring. Thank you very much. And well, I can only add my own words to that because I support those comments 200%.
Well, thank you very much. And again, to everybody here, thank you. I'm sorry I couldn't get to all your questions, but believe me, there's a community. We'll be able to answer whatever you have. But do thank me, and please keep learning. That's our goal here, right? It's just as Paula was saying, the more you know, the more you grow, right? So please keep and again, thank you very much for all the time here.
Thank you. Good day and good night.
Thank you. Good night.
All right.
Bye.